I'd like to introduce Peter Coffey from Salesforce. Again, it's a really pleasure to have him back. We've had him before on the program, but he's got a really timely talk for us. These are hot off the press slides. I think as you'll see probably in the slides, I'm pretty sure there's evidence of that. But exciting topic, really timely. Really glad to have Peter on. Peter, thank you very much for joining us and sharing this talk with us. So really appreciate it and would love to hand it over to you at this point in time.
Well, it's great to be with you. I appreciate the return invitation. Doing these things is always such a catalyst to trying to figure out, well, what do I actually think about that? It's like, Schrodinger's cat. You don't really know what's in there until you open the box and find out if the cat's alive or dead. And thinking about this word metaverse, which has been around now for 30 years, and thinking, to what extent do the most recent things happening inform and illuminate and enable some of the ideas that were being discussed at that time. Alan, if everything's working right, you're seeing a Salesforce logo on a contour map right now? Okay,
yes.
Then Zoom didn't manage to push a mandatory update in the last 10 minutes, so well done. Yeah, I'll show you in a minute what popped the phrase dimensions of change and measurements of a metaverse into my mind. But I'm going to be trying to establish a couple of things this evening. One, are we moving in the direction of this idea becoming a more meaningful and useful reality? And how many definitions of success are there? And what is the risk of achieving success in the eyes of various interested parties that is not a success from the point of view of other stakeholders? Because this is an area in which we are engineering an environment in which we're going to be living a lot of our lives going forward. In fact, to a considerable degree, we already are. And some of the things I'll be pointing out this evening will reveal that the metaverse snuck up on you while you weren't even noticing it. We didn't need Facebook renaming their parent company to legitimize the idea. It's generally agreed that in the same way that William Gibson gets credit for the word cyberspace, that Neal Stephenson really gave us the word metaverse by using the notion heavily in a 1992 novel, Snow Crash. If you have not yet read it, I envy you the opportunity to read it for the first time. The first page had me absolutely hooked, and the rest of the book did not disappoint. The degree to which it described in 1992 phenomena that really did unfold later on. If you've read John Brunner's Stand on Zanzibar, if you've read Neuromancer, then Snow Crash definitely also needs a place of honor on your bookshelf. Interestingly, Neal Stephenson was recently interviewed on the subject of the Facebook parent company changing its name to Meta about, well, what were you thinking in 1992 when you wrote the book? Because it was far beyond the available popular technology of its time. How did you do that, essentially, was the question. Well, he was doing work with advanced 3D graphics at the time, which were hideously expensive, not terribly good, and enormously skills intensive. And he thought, gee, it would be great if more people could enjoy a better version of this capability, because it was already pretty exciting to imagine. And he asked himself, what would have to happen to make it cheap and ubiquitous as television, and thought, it's got to be a mass market application. He didn't visualize that we'd all start doing 3D CAD. He said, what would make this a consuming offering that would drive the kind of volume needed to give us, for example, our partners at Salesforce Accenture are buying 60,000 Oculus headsets to overhaul in a pretty fundamental way their entire process of bringing in new hires, onboarding them, doing training, and so on. They're making a substantial cutover to this as a new normal way of doing things, but that really depends on the availability of a remarkably high-grade piece of hardware for what John Roach at Tandy, back when Tandy Radio Shack was a thing, used to call the one spouse pricing level, where if one of two members of a couple went out and bought it without the other's permission, it would not precipitate nuclear war. Technology, however, only paves the road. It is not the force that makes things happen. Peter Drucker has famously said, invention does not become innovation until it achieves adoption, and adoption depends on, well, what's in it for me? There are two wonderful videos out there. The links are here You'll notice a number of my slides this evening are illustrated with what looks suspiciously like screen grabs of tweets. That is exactly what they are. And so if you go out to Twitter and just find me under Peter Coffee, no punctuation, in many cases, you'll be able to find, in effect, the footnotes to the slides and exercise these links directly. But one of these videos, called Amazon Bay, talks about the unfolding forces of the economy, while another one called Google's On talks about the unfolding forces of media and the idea that these things can come together in really amazing ways. The timelines turn out to have been a little ambitious. These were done at a time when projecting something in 2015 represented a future cast. But if you look at some of the interplays of the forces of money, of entertainment, of people who want to shape agendas by controlling the feed of what's called news, you'll realize that these really are the forces that interact to create adoption for the technologies that the engineers, may be very good at producing in the labs. But what I was struck by was Gartner's list recently published of their top technology trends for 2022. Because as I was going over that list, it just hit me that any one of these not being done well will really gut the prospects for a metaverse, unified, interoperable, standards-based, immersive reality environment in which we can work and play and be entertained and exercise healthcare and education and all the other things we want to do. Any of these trends not being pursued effectively, cost-effectively, governably, scalably, would really limit the prospects of a metaverse. What I'm talking about when I talk about the metaverse is a straightforward parallel with what we've all seen on the internet. Some of us remember when getting stuff on the net required you to know where it was. You had to be able to FTP or telnet to an address. Someone had to give you over the phone or over email or something, a set of numbers and a file path to which you could go get things if you knew they were there. It was essentially a command line kind of environment. And then we had the walled gardens of things like AOL and CompuServe and MSN. And then with remarkable speed, it seems as if the walls just evaporated and all of these things coalesced and just became branded portals to the shared web, to the relatively small set of open protocols that allowed almost any content to become available, discoverable, consumable, without the permission of any master planning operation. And taking the walled gardens of VR with things like Second Life and other specific virtual reality environments, breaking down those walls and letting you move freely among them in the same way you would move among the stores of a shopping mall. They can each control a lot about their appearance and behavior, but being able to move easily among them and share assets between them, this I think is a straightforward thing to imagine happening. And the question is, well, what do we have to do to make it something we're going to like? Because if we do it right, it's not going to replace or displace things we do, but it is going to extend and enrich them in areas that are going to improve our access to health, our manipulation and operations with our financial resources, access to education in a global way, in a democratizing way, create new enriched forms of education, offer opportunities for productive work to people who've not been able to participate in the economy when it depended on going to places and being on planes or going to offices, and all the other institutions and processes of life. So much of what I'm going to share with you now is kind of unpacking almost each one of these trends, not every single one of them, and looking at where we are and where we need to go to make them necessary and viable ingredients for a useful metaverse. There were two concerns that I had. One is the definition of our distance from success. I saw this chart and it actually inspired the title for the talk tonight. There are so many different ways to talk about the idea of distance. If you're in Manhattan, New York, distance is only traversable north, south, and east, west. And so, straight line distance is irrelevant. The only thing that matters is the routes you can follow. Cosine distance, of course, is different. Euclidean straight line distance, different. The idea of distance between different spaces in a solution set. The idea of distance is worth discussing because there is no one definition of, well, how far away are we from that thing you're trying to do? But the other thing is an expression called Goodhart's law, which is that when a measure once we've agreed on a measure of distance, when a measure becomes a target, it stops being a good measure. All measures can be gamed. People will find a way to achieve the target value of some KPI they've been told to pursue, even if that's not the result you intended. And one of the popular analogies is that if I pay you by the number of nails you make for me, you'll give me a box of little wire brads. If I pay you by the number of pounds of nails you make for me, I'll get a small stack of heavy, massive railroad spikes. And neither of these is what I actually need, which is nails I can use to hammer 2x4s together to build a house. So be very careful what metrics you pick. The numbers that are most easily measured, the numbers that have the highest quality in terms of precision and accessibility, may turn out to be numbers that are easily gamed, and people can meet the target while not actually achieving the outcome you had in mind. And that's something I'm going to try to show how we might recognize the possibility of that happening and avoid it during the rest of what I share with you this evening. The sheer amount of data, the data fabrics trend mentioned by Gartner, the magnitude of data movement in the planet today is something we talk about a lot, but this graph particularly struck me. The number of TikTok videos watched in 1 minute, the number of Twitter posts in 1 minute, the number of Google searches done in 1 minute, the number of Slack messages exchanged in a single minute. The zettabyte is 10 to the 21 bytes. I didn't need to know the prefix zetta until quite recently, but the idea that in 2012, all the data on the planet, including what was in the web, what is stored in our digital cameras, what was in our phones, all the data you can imagine could be plausibly estimated in 2012 at around 1 zettabyte. We entered what has been called the zettabyte era. Well, by 2020 alone, we already had 40 of these. The hockey stick growth of the volume of data requires us to get away from having silos. Silos cannot scale. We need to find ways of making data shareable without compromising concerns about privacy, accessible without compromising concerns about confidentiality, which is a different kind of thing, durable without completely overwhelming our ability to store the stuff, accurate and timely without demanding ridiculous amounts of network bandwidth being used to move stuff around that says, nope, nothing changed. Nothing changed again. Nope, still nothing new. Well, we can't record that 3 times. We have to find smart data fabrics that know how to share what's relevant and interesting. And one of my favorite examples is that if a Tesla Model S drives down the street and its machine vision recognizes the pothole and dodges around it, okay, that's a nice little tech trick. The fact that the next Tesla coming down that street doesn't need to see and recognize the pothole because it already knew it was there, because it was in that region and the Tesla network knew, oh, you're in that same vicinity. Is there anything I need to let you know that's new information that might affect your driving? Oh yeah, you need to know about this pothole. That's what a data fabric is. It's not a database in which you have to know what you want to issue a query to get it. It is a interoperable mechanism in which data can move around and in which algorithms can drive it to the places where it's going to be valuable instead of depending on people to know that it's there and to request it. This matters because knowing, as it turns out, is harder than thinking. In 1955, when the phrase artificial intelligence was first put in print, it was thought that this would be a project of maybe a few months duration for a small team to figure out what the mechanisms are of logical inference and deduction and other pieces of thinking. And then once we had that done, a general machine intelligence would emerge straightforwardly. And it turned out that decades later, they were still trying to solve problems of common sense, recognition of everyday objects, understanding of what they mean, understanding that if a ball rolls into the street when you're driving along, a child might follow it and you should be anticipating a need for a sudden stop. That kind of connection of raw data with inference and understanding of the real environment. And for example, IBM is working on a project with some people who are building an autonomous ship named the Mayflower that's going to cross the Atlantic Ocean in a completely autonomous fashion. And to do this, they had to build a database of millions of images of things that float and what they look like in different kinds of weather and under different lighting conditions, so that the boat can make appropriate decisions about what to try to go around, what to turn and run away from, what to see and avoid, but not worry too much if it hits it. These are common sense decisions that any afternoon sailor makes without thinking about them. And that's one of the problems. When we do things without conscious thought, we tend not to be very good at explaining how we make those decisions. And that is one of the challenges of a data fabric is, when do you need to know that? When should I use a finite resource of network bandwidth, a finite amount of computational capacity, a finite amount of user attention span to share that information? Doing this all securely, some people think, is just a matter of building thicker walls and having more complex password requirements. It really turns out that in a lot of cases now, security is way more than permission management. Permission management is easy, relatively speaking. It's algorithmic. You can enforce password complexity. You can demand two-factor authentication. You can introduce biometric tools that are less prone to spoofing and forgery. But the other kind of security is understanding your dependencies. When Tesla owners were unable to get into their cars, that was the first time some of them discovered that the app that they use to control their vehicles is being mediated through remote cloud resources that they do not see and cannot control. But when they go down, it takes them down. We've also had some very high profile incidents just recently in the world of open source, where the Log4j library turns out to be deeply embedded in a strikingly enormous number of systems, and in many cases, 7 or even 9 layers deep in the code. And scanning code for dependencies is almost straightforward, but scanning the code for clones of the Log4j code turns out to be much more difficult. And the other thing that recently happened is when 2 open source packages were intentionally sabotaged by their owner, their operator, with, shall we say, logic bombs as a sort of act of resentment and protest against the use of this code by people who could afford to pay for it and are not. And it all harkens back to the famous XKCD diagram, with all modern digital infrastructure depending on one tiny little piece of code that some random person has been maintaining as a volunteer activity or almost a hobby since 2003. You might have thought that that cartoon was satirical until incidents like these just in the past month had exposed the degree of unknowing dependence on invisible blocks of code maintained by unknown parties with whom you have no custodial, financial, or judicial or legislative relationship. The brittleness of the whole system has been substantially spotlighted just during these past few weeks. Interestingly, in the last 20 minutes before I began speaking with you, I added this slide because today, the FBI put out a warning that what look like innocent QR codes in the corner of a billboard, or maybe a QR code on a parking meter that you think is going to allow you to pay your parking fee, from your smartphone. It may be that when you access that QR code, it appears to have done what it was supposed to do, but it may also have executed a man-in-the-middle attack and stolen your credit card credentials that you were using to pay for your parking in the process of you conducting that transaction. And this is such a remarkable parallel to a piece of text from Snow Crash in 1992, when a character in a virtual reality environment is handed a virtual reality version of a business card, that is to say, something called a HyperCard back then. And his character thinks, I'm not going to touch that thing. It would be like taking a syringe from a stranger and sticking it in my neck. It could infect me with any number of viruses. It is extraordinary to think that in 1992, we were hearing something, envisioned that looks so much like what happened in this story that just came out today, where an innocent looking entry point to a convenience feature of an environment turns out to be malevolent and capable of inflicting actual harm upon you. Doing this all privately is another thing. There's security, which is only the people who've been authorized by the system operator can look at it. And there's privacy, only people who are trusted by the person that the information is about are allowed to see it. Security and privacy are not the same thing. We've already talked about the degree to which Tesla owners had their car door being opened for them by some remote cloud server that they had never seen before, which essentially would be very likely to have in it as a byproduct a record of where they were and when every time they accessed their car. I'm not sure if that's a database that you would necessarily want being held by someone you've never met. Well, Internet of Things protocols have been notorious for exposing people to that kind of thing. There is a new protocol that is being developed by a consortium, including most of the big names in home smart devices, called Matter, that is designed for local operation so that a number of things are true. Number one, you don't have this data leakage. You have the ability to continue operating autonomously, even if your internet goes down. It's a very important step toward a metaverse, where now we have a non-proprietary protocol for things like your smart speakers and your smart appliances and your smart door locks and all of the other things that make a smart home smart or occasionally infuriatingly stupid. This is a big step in the direction of kind of an invisible fabric of action and awareness that will allow these things to work together in a really interesting way. Making this happen is increasingly going to depend on robust encryption. And with quantum computing no longer a speculative possibility, quantum computing is no longer something we might be able to make work. Now it's really an engineering thing of how big can we make it at how low a price, how quickly. You can go on public websites now operated by people like IBM and begin working on how to write code and algorithms and processes for quantum processors. That's already a thing. You can already buy commercial quantum hardware if you really, really have the need. And among the things that quantum computing will do is take most of the current state-of-the-art in encryption protocols and turn them into, Swiss cheese or tin foil or whatever your metaphor of choice is for something that's easily evaded or destroyed. There is such a thing as a post-quantum encryption infrastructure. There are National Institute of Standards and Technology evaluation processes already underway to choose standards in the post-quantum crypto space in the same way that we have things like advanced encryption standard in the current crypto space. But if you're not thinking now about getting on board with implementing those, then 5 or 6 years from now, when quantum processors are available and can attack your current archives, they will not have been encrypted at a level that's safe against that kind of thing. It would be like having put things in a cardboard box before X-Acto knives were invented. And then when all of a sudden everybody's got a knife that can easily cut through that box, discovering that the box no longer provides meaningful protection. This is where we are. People need to be looking over the horizon at the availability of quantum attack modes against their data if they want it to be robust for more than, at this point, I would say, medium to upper single-digit years. One of the things that encryption is particularly important in doing is electronic payments, and also in end-to-end encryption of messaging traffic. So far, these have been kind of separate things. You've got applications like Telegram and Signal, widely used. I know many people who use Signal just as a matter of course, because it's completely encrypted end-to-end. They have occasionally been subpoenaed, as have the people operating Telegram, and authorities have demanded access to message traffic between suspected criminals, for example. And they've said, we'll give you the metadata. We can tell you when they exchanged messages, but we have absolutely no way. No computer currently existing within the state of the art could tell you what those two parties were saying to each other. Law enforcement finds this very frustrating. The Prime Minister of Australia famously said, the laws of mathematics are well and good, but in Australia, the laws of Australia shall prevail. And people had gently to explain to him that it is actually not possible to say the laws of Australia require you to crack that encryption algorithm. It just can't be done. What this does, and this is maybe the first time tonight that I brought this up, is create a whole new dimension of inequality. It used to be, as was said in this piece on the Register, that the poor were invisible. No one cared about them and no one really knew what they were doing and they could just live their lives. Well, now privacy is expensive. Privacy is becoming the privilege of those who can pay for it, the privilege of those who can pay for VPNs, the privilege of those who can pay for the vastly greater amounts of processing power required to process post-quantum crypto algorithms. it's a dimension of inequality that's going to have to be considered before it's just allowed to metastasize, as so many other aspects of the digital divide have done. And all of this is happening in cloud platforms as a matter of scale, as a matter of cost effectiveness. Cloud platforms allow us to throw extraordinary amounts of computational power at tasks for short periods of time. Maybe it's not obvious how important that is, but it used to be if you had a problem that really needed several million parallel processing nodes, but only needed them for 10 minutes, you were kind of out of luck. You needed to make a capital investment in that kind of power to have it available when you required it. But now people like astronomers doing detailed modeling of the atmosphere of Jupiter can find significant new mathematics that turn out to have all sorts of spin-off benefits in analyzing other kinds of massive chaotic data sets. Interestingly, we've got another snow crash reference here, because at one point, just in passing, they're hanging out in a virtual reality environment and someone is smoking a cigarette, and the smoke from the cigarette swirls in a realistic way in the virtual reality environment. And the narrator just kind of observes in passing. It takes as much work to do that as it takes to model the weather system of the entire planet Earth. Well, now we can model the weather system of planet Jupiter, and we can do it for the 15 or 20 minutes, or maybe 15 or 20 hours. But we don't have to own that power to do it. This is wonderful. This changes so many things in terms of our ability to do processor-intensive but short-lived tasks that create understanding of new truth. It's really, really exciting to be able to do that. But doing this requires two things. One, there have to be places like, for example, not very far away from you, the Supercomputing Center at UCSD, one of the world's most amazing facilities. They did things like analyzing the hydrology around New Orleans during Hurricane Katrina and producing 24-hour forecasts in way less than 24 hours, which obviously is kind of necessary. A 24-hour forecast that takes 25 hours to produce is not very helpful to anybody. But I happened to have an opportunity to visit with them there. They said the real heroes of the day were not the people who worked out the algorithms for modeling the hurricane and the water flow. They were the people who knew how to tune the FTP, file transfer protocol, to move the data from Louisiana to San Diego quickly enough that they would have time to do something useful with it. And you may have heard the expression that nothing has more bandwidth than a shoebox full of DVDs in the carry-on bag of someone on a plane. Moving the data around on hard drives or on today, of course, they'd be solid state drives, getting on a plane and carrying a piece of data storage hardware is still in many cases the fastest way to do stuff. When they're shooting movies, for example, and it's all being done digitally, they put people on planes with hard drives because that's the only way to get the bits back to the studio in a timely way. This interplay between the movement of the data and the operations on the data is going to create an interesting tension between two different classes of cloud service provider, the computational clouds like Amazon and the bandwidth clouds like Verizon. And who's going to be in charge? Which one is going to be in control of the scarcer resource and have the pricing power? What kind of business models will emerge is still a work in progress. Because one of the important things to understand about 5G is that it's really not just a faster version of 1G, 2G, 3G, and 4G. 5G represents a qualitative change to where the network is more of a computational fabric that also imitates the functions of a traditional circuit mesh. And the degree to which operating a network is really operating a big distributed computer, and operating a big distributed computer is really operating a network. Well, this coalescence of these two worlds is going to produce opportunity and contention, and probably a lot of disputes that are going to be settled by lawyers rather than by engineers. Trying to do this in an agile way really flies in the face of a lot of things that we have been told, and that I at one point 20 or 30 years ago was teaching people about how to do good systems design. We tended to do what I called pyramid building, where you spend a long time on your requirements analysis because you know that as soon as you start building the thing, you're kind of locked in to the vision with which you began. It's a little hard to change your mind as soon as you've started building a pyramid. You're kind of committed to that pyramid idea. And if something happens that's so drastic that you have to say, oh gosh, we really don't need a pyramid at all, we really need a cube, you're kind of always going to be able to tell that that was not plan A. We really can't do this anymore because the time it takes now to have the problem change is now so much shorter than the time it takes to do traditional requirements definition and laying out of the complete architecture and then building it exactly right and then being stuck with that for a matter of years simply can't function. There is an alternative, which is to build things intentionally from composable and recomposable components. We've talked about this since the first time I went to an object-oriented programming systems and languages conference in San Diego back in 1988, when Mitch Kapoor, then well known for Lotus, talked about object libraries emerging. But you know what? Back then, bandwidth was such an impoverished resource. We had to talk about object libraries as something you would buy on a floppy disk. The idea that you would have anything like the Log4j library or the libraries I talked about a few slides ago in the open source world, that was really difficult to visualize at the time. Now we can have that. We can intentionally architect systems in a highly composable way. It takes more work up front to have semantically complete interface sets. It takes more thinking to provide discoverability and repurposability of these things. But when you do it, you wind up with this kind of Rubik's Cube ability quickly to say, oh, okay, I need something just like that, but I need you to twist that layer one notch around, or even unfolded and refolded into a substantially different shape. This is necessary because in this world of data fabrics, the hairball of connection just becomes completely unmanageable. If you've got a vision of interacting data based on connections among the various sources and consumers of data, well, you remember your basic combinatorics. The number of lines in this diagram goes with something like the square of the number of points that are interacting with each other. That's unscalable. It's ungovernable. It's very difficult to make it evolve. It becomes just a mess. Moving to not a diagram of connections, but a library of APIs so that you can treat every new source of data as additional pages of new verbs of the language of action instead of being a set of new connections that changes the whole diagram. This is a key transition to make. It is actually the principal reason why Salesforce bought MuleSoft rather than any of several other integration providers, is because we visualized this need for a repurposable library of APIs being the essential defining viewpoint of what data connection was going to represent. This brings us to the subject of AI, because when we're dealing with this kind of scale, when we're dealing with this kind of complexity, trying to do this at the speed of human brains is probably what will, and we have limits on our imaginations of possibilities. But back in 1955, the idea was we'll understand logic, we'll understand inference, we'll understand the things these things do, and then we'll build machine intelligences that do what human intelligences do. We'll build expert systems. This turns out to be much harder than they thought, and maybe not the most valuable thing we can do. I want to share with you this recent example. Some of you are probably familiar with the Asian origin board game of Go. It's an extremely complex game. It's been characterized as having a game tree complexity of 170. Compared to the task of competing in the America's Cup, where the sailing problem has a game tree complexity of nearly 3,000. The number of decisions to make, the timing of those decisions, the interaction of the sequence of those decisions is that extraordinarily complicated. That people can do it at all well is one of those amazing things the human brain can do. Well, they used some basic AI mechanisms to build a simulator so that the sailors, the competing teams, could practice against the machine as if they were sailing against human opponents, as if they were sailing on the real water, and work on tactics, work on strategies for how they would win under real conditions. and something unexpected emerged. They found the simulator generating original, unusual strategies. It did things that they'd never seen human teams do before, and they were really interesting things to do. And they wound up studying the simulator for new ideas on competitive maneuvers that they themselves might execute in some of the world's most elite advanced competitions of some of the most complicated and brutally physically difficult things to do. This idea that human and machine will interact with each other, and that each will inform the other, and each will show the other things it has never seen before and maybe would not be able to devise on its own. This is a much more interesting way of using the mechanisms of AI instead of using them to build bad imitations of what people used to do, because so much of machine learning now is, in fact, let's look at the last 3 years, run it through a machine learning sieve and build a robot that does what we were doing during the last 3 years. I think we can all agree that last year, doing what you'd been doing during the previous 3 years would probably not have been a very effective strategy. Automating this is, in fact, a dangerous idea. Automation is repetition in most cases, or maybe navigation of a fairly static decision tree under fairly well-known circumstances. IBM back in 2005 started using the word autonomic, and from which I backformed the word automation rather than just autonomics, to talk about systems that are actively anticipating changes in their environment, actively acknowledging the possibility that what they do won't go perfectly the first time and might have to be done again, building systems with a kind of feedback loop that had not been done before, not the simple feedback loop of a thermostat, but a much richer kind of feedback that anticipates errors and that is a self-healing system that can recognize its own mistakes and repair them, can do majority voting among different parts of itself and say, okay, this sensor is probably the unreliable part. So many systems fail because a flawed sensor, like the angle of attack sensor in the Airbus aircraft that caused the plane to crash, or the things with the 737 MAX, or the angle of attack indicator was not reliable and triggered a system that was doing what it thought it should do, but was incapable of diagnosing the errors in itself. And of course, there were also other decisions made, like having only one indicator instead of two sensors that could have had a chance to correlate against each other. This kind of sensibility of building systems in depth with this kind of resilience is something we really need. Unfortunately, what's happening now is that AI is being treated as kind of a genie in a bottle, and we actually have pieces of legislation being introduced that say things like, well, let's just go ahead and clarify that AIs can prescribe drugs. And I thought, this has to be an oversimplification of the legislation that was introduced. Surely no one would just propose a law that says that artificial intelligence and machine learning technologies can qualify as a practitioner under various food and drug regulations. So I went and looked up the actual legislation. And sure enough, that's what the law says. In this subsection, the term practitioner licensed by law to administer such drug includes artificial intelligence and machine learning technology. Oh, well, then I guess we're okay. The idea that these things are so well defined, such a mature and well understood technology that we can just drop them in like fairy dust into a task like prescribing drugs is symbolic of the kind of failure to appreciate how immature and how nascent so much of this technology really is at this time. A lot of these things need to be done with partnerships of companies. A lot of the things that you rely on every day, you order something off the Amazon website, it's actually supplied by a company that Amazon does not own, that's using Amazon as its storefront, and then it's delivered to you by a shipping service, and you get an email that says your order's on the way, here's the shipping link, and it's all been made wonderfully convenient for you, but the complexity behind the glass is considerable. Doing that now is difficult because you got to have invoices going back and forth, people need to pay each other, it's difficult to scale, it's difficult to control. Walmart in Canada estimated that I'm trying to get the number right, 97% of the invoices of its trucking included some kind of dispute resolution. Just a completely enormous percentage. There was some kind of question about, well, should we be paying you for that because that delivery was late? Or should we be paying you the full price because that shipment had damage or whatever? And that was just chewing up enormous amounts of money because of the traditional siloed architecture of the data. A distributed enterprise in which something like a blockchain, I try to avoid the word blockchain because it's a special case, a distributed ledger like Ethereum with smart contract capability can dramatically improve this situation. When Walmart Canada moved from traditional databases firing messages back and forth at each other to a shared cryptographically protected data structure that does not require one party to be the most trusted party, they cut that dispute rate down to 2%. And that's today, that's present reality right now, not some future prospect. That's really great. And we need to use these things effectively, not be distracted by cryptocurrencies, but understand the underlying data model as having tremendous power. And in fact, this is not a matter of recreational capability. This is a matter of recognizing the enormous acceleration where those gray dots represent tasks that companies were doing on a quarterly schedule only a few years ago. And the blue dots represent the companies now having moved those in the most recent year. The gray dots are pre-pandemic. The blue dots represent current practice where these things are being done weekly or in some cases even daily. The tightening of the decision loop, the tightening of the application cycle where updates get handled with extraordinary speed. It's tremendously important to appreciate the impact of this acceleration on all of this. This has been described by borrowing an idea from the Air Force of the so-called OODA loop, observe, orient, decide, act, the ability to be taking in data, filtering it for what matters to you, making decisions based on what that filtering tells you, and then executing the decisions. If you get any one of those things wrong, you wind up being the one getting shot down. So using this model for air combat has been very effective. And this is an example where our chief financial officer talked about how at the end of the quarter, we have our fiscal year end coming up at the end of January. So this is a pretty timely example. At the end of the quarter, our CFO, our CMO, our CEO can all be looking at their phones, know they're looking at shared truth, know that they can make a decision like someone needs to call this prospect in the next hour to make sure this deal closes before midnight. That kind of tightening of the loop is a reality, and it's fantastic to see it happen. But the OODA loop isn't as simple as it's sometimes drawn. It has to acknowledge outdated information. It has to acknowledge bias and point of view. It has to acknowledge the need for turning hypotheses into testable experiments and then into actions that can be taken within the available time and other resource limits. It's really exciting when it happens. When we can't do it, we notice. At one point, for example, on a single moment, I found the following headlines. 4 days ago, boat stuck in Suez Canal. It's going to take at least a week to get it out. You're all hosed. It might be a month before the canal is operating again. Oh, wait, 2 days ago, when you were already diverting your ships around Africa, you didn't know that 1 hour ago, the canal was going to be cleared. Trying to do decision-making in this environment where you need to make committed decisions like sending a great big ship around the tip of Africa instead of through the Suez, when the situation can change that quickly, really taxes traditional systems. McKinsey has observed we've got this major problem now. The reports are out of date even before the managers get to read them. And further, the phenomena being reported have characteristics like exponential growth, which most people just don't process very well in their brains. This is why traditional approaches to planning are really overrated. In fact, it's been said by everyone from Mike Tyson to General Moltke that all plans, as soon as anything actually interesting happens, kind of become garbage. But Dwight Eisenhower put it very well. He said, it's not that the plan is garbage. It's that you develop the mental muscles, the procedural habits of being able to generate a plan. And so when the facts change, yeah, you throw away all the old plans, but you know who to call, you know who you want to have in the room, you know what data sources you're going to trust, you know what parties are going to be able to carry out the immediate actions that have to be ordered. these planning muscles are developed through exercise. And even though in the same way that you pick up a weight and you put it back down, it looks like nothing happened. Yeah, but you built your muscle for the next time you need to pick up that weight. And the idea that constantly planning and replanning, often aided these days by machine intelligence, by execution of iterative algorithms that are continually generating new plans. This is a very powerful interaction between human and machine. We have to stop thinking that change is unusual. Tom Peters famously wrote the book In Search of Excellence. Not so famously wrote another book 2 years later called Thriving on Chaos that apologized for In Search of Excellence. He actually did. He actually said the problem with In Search of Excellence is that it told you there were certain habits that were the behaviors of excellent companies. And it turns out that the most important behavior of excellent companies is that they continually change their behavior. And that when they went back and looked at the companies they'd profiled in 1985, the ones that had changed the least were the ones that were in the biggest trouble. And that adaptability was the new excellence. This has also been recognized by academics who are literally using the TV series The Walking Dead as a set of scenarios for doing contingency planning. But they made a key point. It doesn't help to know that there are zombies if you haven't built a plan for what to do when you meet one. And so this idea that we're continually generating and regenerating new plans is important. I've talked a couple of times about acceleration and growth. It's easy to get the idea sometimes that these are trends and that everything is always accelerating, everything is always growing. They really aren't. There are important exceptions. I mean, yeah, it took us a long time. It took us 140 years to go from having almost no houses with flush toilets to having almost all houses with flush toilets. It took a long time to get that technology adopted. Only took about 8 years to have smartphones achieve that same level of adoption. Okay, but those are both positive trends, right? Yeah, but there are other trends that are a little more complicated. Landline phones took 73 years to get from 10% to 90% of American households having a landline phone, but now that number obviously has been shrinking, the so-called cord cutting behavior of the last 2 years. What makes trends stop and reverse? This was described by Peter Drucker with a phrase that I actually used on a slide when I saw you guys in 2017. This Drucker quote is on one of those slides. If you want something new, you have to stop doing something old. Getting organizations to stop doing familiar behavior is often much more difficult than getting them to try something new. And George Gilder talked about this in 1996 in a great article in Wired. He said, eras change when something that used to be scarce becomes abundant, or something that was abundant becomes scarce. The first industrial revolution. Why did it happen? Because all of a sudden, land, which had been abundant, was all pretty much carved up. And so you couldn't just go out and find an empty piece of land and start farming. Meanwhile, horsepower, which had been scarce, suddenly became abundant. And so people left the farms where land had become scarce and went to the cities and the factories where horsepower had become abundant. And you moved an entire population from rural to urban, from agricultural to industrial. It happened because of those things, not merely because you had steam engines, but because they created an abundance, while at the same time, there was also a countering scarcity. So what's abundant now? Well, for one thing, connection. I've emphasized here the light green curve because the over 65 population has gone from having hardly any broadband internet in their homes to being pretty much right up there in the same space as the younger generations. This is no longer a generational thing. Old people are on the internet, they're doing digital banking and digital healthcare. This is no longer something you do to go after the younger generation, millennials and Gen Zs. The whole population wants to live in this connected environment. And they've got the computing power to do stuff with it. These are logarithmic scales. If I put these things on linear scales, they would just be completely hockey stick type curves. We've got the power to do things with that data, and we can do it with very little electrical power. The electrical efficiency of the supercomputer in your pocket, called your smartphone, gives evidence of that. These are the new abundances. What's scarce? One of the things that's scarce now is the ability of the human brain to keep up with all of this. I don't know if you've ever heard of the Ebbinghaus curve of forgetting, but it turns out that the first time you hear something, within a matter of days, you've forgotten most of it. unless a properly timed repetition and then another properly timed repetition, think of it as a booster shot for your memories. This is provably shown to have tremendous effects in permanent memory of the things you're being taught. What we need to do is build systems that don't just assume you've been shown this thing once, therefore you know it. No. We have to build systems that interact with the user and reinforce the things they need to know if we expect them to remember them at the time that that's important. This is a challenge because the other thing becoming scarce is access to the human attention span. There's simply so much competition for the finite resource of people's attention. And you know what? The brain conspires to make us look at new things. We actually get a dopamine hit when we find something new that we haven't seen before that's exciting or interesting or stimulating. And so if you're building systems today, you have to fight the chemistry of the user's brain to keep them involved, to keep them paying attention long enough for action to take place or memory to result. A lot of the questions going on right now are, well, what about last year and the year before? How much of this stuff got accelerated by the pandemic? How many things did we learn? Well, what did we learn in 2020 and 2021? Well, we showed that organizations that already have networks and relationships and products and customers can re-platform if they don't mind operating at a burnout pace. That's what we really showed. What most organizations haven't yet figured out is how to hire new people in this environment, how to build new relationships with new customers and new partners, how to develop and launch new lines of business, and how to do this sustainably. Someone in the New York Times put this very well. They said, if you are in a shipwreck and the top of the piano from the piano bar floats by, you might climb on top of it and float on that, and it will get you through the night. But the next time you're equipping a boat with life rafts, you won't go to the piano store and order a bunch of piano lids. And the things that got us through the last 2 years are not necessarily things we should continue to do, even if they are things from which we can learn what we should do. For example, I'm sorry, before I leave this chart, the reason it's important to do this is that business leaders expect that half of their revenues 5 years from now will come from products that don't yet exist. So this is why it's important to get beyond the getting by stage that we survived on during the last 2 years and say, yeah, but how do we function with hybrid work? How do we function with a multi-generational and more diverse workforce operating across more national boundaries than ever before? How do we figure out how to make this work, even if it doesn't look like what we're used to handling? Which brings us to this question about, well, okay, how do we measure whether this works? How do we measure if we're doing this? Why do we need a different word than cyberspace? Well, William Gibson in 1984 used the word cyberspace to talk about connecting computers, abstract representation of data, places where cyberspace cowboys would know what those abstractions meant and be able to do amazing tricks or maybe perpetrate spectacular crimes in that space. Back when Mark Zuckerberg was one of the good guys, or widely seen as one of the good guys, in 2010, when Time made him Person of the Year, someone made a key observation. Mark didn't look for ways to connect computers as much as he looked for ways to connect people. And wherever Facebook may have gone since then, I think that's an accurate observation. The reason it achieved what it did and grew the way it did is that it treated itself as a platform for people to connect instead of a platform for connecting computers that computer users could then use. This matters because this leads us to tonight's question: what are the measures of a metaverse? Because it's a place for people and not just a place to co-locate people's computers. What's the economic output that's living in this space? Right now, about 3% of world GDP is represented by cryptocurrencies. The World Economic Forum predicts that by 2027, 10% of world GDP may be living in distributed ledger data platforms. We will rapidly see a double-digit fraction of the world's economic activity happening in this space, probably before the end of this decade. Virtual meetings, 48% for tech activities, only 26% for the doctors. Okay, there are some things you need to do with actual hands on the cadaver, but virtual reality and augmented reality are already penetrating medical education. A lot of things are going to be highly doable in augmented reality settings. And travel, let's look at the train wreck of business travel, all of the assumptions about what kind of trips are worth making, what kind of meetings need to be held face to face, these are all up for grabs. These are the measures of what people do, not measures of what computers do, which is how we measured the web. How many web pages are there? How much data is there? How many servers do you have? No, we're moving beyond technical measures to behavioral measures, to social measures, to economic measures, because the rest of it is just plumbing. And that's really an important transition for us to be making. For example, if you just count the number of messages being sent around a company, as some people were last year, and saying, oh yeah, look at all the burnout of the virtual meetings. Well, that was just a superficial aggregate number. It turns out that the messaging between people who knew each other was growing at by leaps and bounds. But messaging between people who did not know each other plummeted. The speed of developing new networks, of onboarding new people, that was seriously limited during the last 2 years. We have to figure out a way to fix that if we're going to deal with that McKinsey observation, that half of what we are making our money from 5 years from now has to be stuff we haven't invented yet. When I was at Exxon, we used to say, because of the way mandatory retirement worked, that sometime in the past 10 years, we must have hired a future chairman of Exxon. And the question was, well, who is it? How do we make sure they don't leave? These questions of pipeline, of where's the talent coming from that's going to grow your company to where it wants to be 5 years from now, these are really important questions. These are not touchy-feely questions. And so we have to build systems that are active platforms for collaboration that allow people to do the right kind of automation that will empower them in ways that today's systems that really just tell the user what to do not do well. The interesting thing, as our own recently published research has shown, is that people don't think of themselves as needing to be, quote, a programmer, unquote, to develop a useful automation. At the point of need, they can generate a valuable automation that makes something happen reliably, more quickly than ever before, without needing to go down the hall and get some pyramid builder to start that long, tedious, laborious process of solving yesterday's problem a week or two from now. It's not like we're rushing this. Anyone who thinks, oh, this is all happening too quickly. No, it's really not. We'd already talked about Neal writing the book in 1992, but in 1964, Sir Arthur Clarke, as in 2001, The Space Odyssey, and so many other powerful works, the person who's credited with visualizing the mechanism of the synchronous communication satellite. It's still called a Clarke orbit when you're up there orbiting the Earth at the same speed the Earth turns. Said that by the year 2000, no one will be traveling for business. Okay, I wish I'd known during 2018, 2019, when I was traveling 200 days a year, that I didn't need to do that anymore. I tried for the 2 years prior to pandemic. I had a goal in my company annual plan of cut my travel by 50%. Couldn't make it happen. The social acceptance that we would do certain things without being physically in the room was not there. I am trying with all my might to turn the experience of the last 2 years into the existence proof that we can do this without burning jet fuel, without spending 2 days to get there and back for a 2-hour meeting. This is an example. We did an executive roundtable in the Netherlands in an application called Glue. That's me up in the front of the room presenting to people who were in several different European countries that morning. And then we went and hung out by the fire pit later on for a little casual conversation. I was astonished at how good this was. I thought it would be something I could tolerate once as a demo. I find myself wishing we could do all of our meetings this way. And finally, an observation made by The Economist. Don't look at the things that you won't be able to do in virtual reality. Look at the things that augmented reality will add and that VR environments will allow us to do that we simply could not do before. To be inside a DNA molecule or a hurricane, to wander around a black hole. Look at the stuff that's happened with the Webb telescope just during the last 2 weeks, the amazing devices that we can put in places to sense what's going on and involve us in that reality. I'm so excited about what the next several decades are going to be, and I appreciate the chance to share that excitement with all of you tonight. Thank you for your time, and thanks for the invitation to be with you.
Yeah, thanks a lot, Peter. Wow, that's quite a talk. It's amazing. A lot of thought-provoking points. Great talk, Peter. Appreciate it again. Thank you.
It was a pleasure to share it.
Yeah,
I learned a lot putting it together.
Okay. Well, you talked as if you've been thinking about all these things all the time. So
That I have been doing for a while. Yeah.
yeah. So at this point, we'll move to Q&A sections.
Let me answer the easy question first. The slides will be made available. I was working on these literally up until about 15 minutes before, because that thing with the QR codes versus the syringe in the neck metaphor from Snow Crash, that only happened today. And so I fortunately was able to drop that slide in while Alan was doing the business session. I will be unpacking the various builds, turning that into a PDF, and I'll share that through the people who organized the event. So they'll find some way of making that available to you. But yeah, nothing proprietary here. I want these ideas out there in people's heads. I want to take over your brains. So I will be very happy to share that. So Alexander, I appreciate the interest, and you'll be getting that material. A more involved question: will we go into the metaverse to hide from our real lives? Yeah, well, the lead character in Snow Crash is literally named Hero Protagonist, as in HIRO, and he lives in a self-storage cube. But as they say in the book, in the metaverse, he's a warrior prince, because he's got fantastic hacking skills and lots of virtual assets. And it's a very interesting question. Already, this has happened. For example, police departments have talked about how difficult it is to identify the most successful drug kingpins, because the old ones had big houses and fancy cars and entourages, and they lived large, and their wealth was conspicuous, and it stood out in their communities. You kind of figure out something was going on. And the new drug kingpins don't do that. They live in a dump. They've got great computers. They enjoy their recreation in virtual reality world. They don't have the same symbols of external wealth that used to be the indicators. So in a way, it's not that they're hiding from their real selves. It's just that what's important to them is different from what used to be important to people. This drives employers crazy, because at one point, for example, they were discovering that people would take a job, work until they could afford to take 3 months off, quit, go backpacking in Europe for a while, and then come back and just get a new job, because they were in such demand that leaving and coming back, we used to say, oh, you can't do that. You can't leave a company after less than a year. That'll destroy your resume. People don't really feel that way right now, and haven't felt that way for several years. And certainly the gig economy mechanisms that we have, it changes that. So your question's really good. Will we go to the metaverse to hide from our real lives? But I think it might be a little bit more complicated than that. It's more like the metaverse will not be separate from real life. It will be like having a different room in your house. When you go to the kitchen, are you hiding from your real life in the garage? No, you're doing what the kitchen lets you do. And it is part of your life. It's a new annex to your life. Now, the question, do I see the positive? Do I also see the negatives? Yeah, I do see the negatives. I mean, we've seen the negatives already in the phenomena that's been described on social media, where you're essentially seeing the highlights reels of other people's lives, and the perception that your life really sucks because it doesn't look like the best parts of other people's lives that you see being shared. Actually, I already mentioned John Brunner's book, Stand on Zanzibar. There's a thing he talked about in a book that he wrote, if I remember correctly, in 1968, that was set in the year 2010, where when you're watching TV, there would be things they could drop in where these placeholder characters called Mr. and Mrs. Everywhere would be doing stuff, and you would have your image in your TV so that you would see your face on the characters of Mr. and Mrs. Everywhere. And when they wanted to show people surfing in Hawaii or climbing a mountain or skydiving or whatever, you would see yourself doing that. And then someone observed something, that people weren't bothering to have their images updated. And so for 10, 20 years at a time, they would see themselves on TV and they'd be seeing their 20-year younger selves doing this stuff. That is a really interesting question, is will we start to think we are the thing we show to the rest of the world, where all the warts have been removed, everything's been airbrushed, and we only show the parts we like? I don't know the answer to that question. There's certainly some behavior already happening that way. Sherry Turkle, from whom I took a class when I was at MIT, has written a book called The Second Self, which asks some of these questions about do invented realities start to crowd out real reality in our brains? It's a really good question. And I'm not going to try to predict the answer. Windsor, he asked in summary, what are the measurements for a metaverse? They really did boil down to that one slide. The focus I was trying to suggest is that the measurements of the internet were technology measurements. There are measurements of volumes and velocities and latencies of data, numbers of web pages served, numbers of messages exchanged, and so on. The measurements of the metaverse are measurements of human aspiration and action. There are measurements of how much economic activity is happening here, how much collaboration activity is happening here, how many hours, how many degrees are awarded in this environment compared to degrees being awarded in traditional classroom education settings, how much experience of new places happens here compared to people actually getting on planes. Will I have my first experience of walking on Olympus Mons on Mars in a virtual reality environment rather than the real one? Yeah, I probably will. I think that's pretty likely. I think I probably will be able to do that. I think probably within the next decade, a private sector rover operating up on Mars will allow me to have the experience of moving around Mars and looking at it and seeing it and hearing it. Won't be real time unless we change the speed of light between now and then, but we'll find a way. So Windsor, I'm sorry if that seems oversimplified, but the main focus I was trying to suggest is what will make it the measure of the metaverse is that it's a measure of human behavior and human activity and human achievement instead of a measure of technology magnitudes and velocities. And I hope that isn't disappointingly simple, but I do think it is not the path of least resistance. The path of least resistance is to continue measuring that which is precise, that which is easily available, that which is high quality. Those tend to be technical measures, and I think they very much risk measuring the heights of the trees in the forest and not seeing the forest for what it is. How do humans keep up with the machines as human evolution is slower? I don't think the humans keep up with the machines. I think we do certain things that machines we have no idea of how they'll do it. Roger Schenck at Yale said that common sense reasoning is a 20-year research problem, but we said that in 1965 and we're still saying it today. There isn't even an algorithmic framework for understanding what you're doing in your brain. There's a wonderful thought experiment that was described of, imagine a robot that will become immobile if it does not go find its own spare battery. And it's been told, go find your battery so you can continue to function. And it uses basic AI mechanisms and finds the battery and plugs it in, and then it's blown up because the battery was on a cart in a closet that also had a bomb on it. Okay, so the robot is allowed to remember this lesson, and it learns to look for the bomb. And it learns and it learns and it learns. And after a while, they notice the robot is just sitting there. And they interrogate the robot with diagnostic tools. And it turns out that the robot is so overwhelmed by figuring out what doesn't matter that it can no longer take action in any useful time. And the point that's made is, think about all the things you are ignoring every time you walk down the street, every time you pour a glass of milk, every time you pick up a pencil. Think about all the things that you are making no conscious effort to ignore, and yet they are not distracting you. We have no idea how your brain does that. We don't know. So doing it with a machine is a long way off. So having a machine that can reliably drive a car, that can drive a beer truck on a highway, well, we've got that now. That's already been tested. We can deliver freight with semi-trailers on well-designed highways. But trusting a car to drive down a residential street and not kill children and hit dogs, we really have no idea how to do that. So I'm not too worried about machines being able to do what I do. I'm very glad that they will be able to do things I don't particularly want to do. So I hope that doesn't oversimplify. The status of the bill in Congress for AI medicine. I don't know the answer. I'm sorry. I could go back and look at that slide and find out who was the principal sponsor of the bill. We can, let me just jump back there and see if that's very quickly identifiable. There are a lot of interesting bills in Congress. The other one that I'm hoping will get reintroduced because it didn't pass in the last Congress is something called the Algorithmic Accountability Act, which has to do with the disclosure of what kinds of data are being kept and what kinds of processing are being done, what kinds of protection against bias in algorithms exist. These are all really, really interesting questions. And right now, these things happen in a completely unregulated space. Okay, here we go. The bill, the bill is, oh, come on. All right. I'm going to have to get back to you on that. When you get the slides, you will be able to see the name and number of that piece of legislation, and I hope that that it will quickly lead you to the answer to your question, which unfortunately I can't give you right now. Observation that he started writing Snow Crash in '88 and then was published in '92. Yep, even more impressive. Don't dispute that. I did not actually know how long he worked on it. I'm not surprised that it took him 4 years. Gosh, I don't know how long it took writing the Baroque cycle then. Okay, let's see. Neuralink type technologies, linking ourselves from our brains directly into the machine. There's been some remarkable progress on that. It doesn't particularly interest me. I think it might have more value in studying the brain than in extending the brain. And I'm not going to claim enough expertise in that area to have a more informed opinion than that. I don't think mechanisms like even our memory of facts. I mean, I've showed you that Ebbinghaus curve of forgetting. The idea that we learn stuff and that the act of being asked to remember it seems to improve our ability to recall it in the future, that the act of recall seems to reinforce the memory in the first place. That's an observable fact. I don't think it's an understood mechanism. I don't think anyone claims yet to understand how that piece of meat between our ears does the things it does, including being able to tap into it. On the other hand, there's been some really crazy stuff done with machine learning, processing signals in the brain and being able to say, oh, okay, that's the brain seeing a dog. So this may be one of those things where it goes from barely works at all to works amazingly well, really, really quickly. Can AI write software? AI already writes software. At what point do many of today's developers be out of jobs? They won't be out of jobs in the sense that AI will write the code they would have written, but they might find fewer jobs because an AI-derived technique will be used to solve a problem 100 times less efficiently than a well-written piece of code would have done it, but it will be cheaper because the hardware is cheap and the people are expensive. So it's not the question that the question I would suggest needs to be asked is not when will machines write code, but when will problems currently solved with carefully crafted, finely tuned masterpieces of algorithmic engineering be solved instead by cheap brute force, because the brute force will be so cheap. And that's already happening. I mean, that is already happening. Will the metaverse just replicate the divisiveness of Twitter, et cetera? Yes. Yes. The degree to which we have already seen the positive feedback loops that result in the fragmentation of audiences, the fragmentation of people's beliefs in what is fact and what is not. We certainly have the opportunity now to reproduce that at great scale. And I don't know what the answers to that look like. I do, however, I have seen a very interesting experiment that was done. I think I saw this on 60 Minutes just recently. They did a project where they got people with dramatically different political views and paired them at random, but one person from one camp and one person from the other camp, paired them in a room with a moderator. And the first thing they did was each write a short biography of themselves and then have the other person read it aloud. And that simple act of having the words come out of your mouth, in my case, I'm a Black single mother who had to drop out of high school to raise my first child. I live in a high crime neighborhood and I'm completely dependent on the social safety net for my basic survival. Having those words come out of my mouth forces my brain to process those ideas in a really profound kind of way. And they've found that when people are in that situation of being made to experience each other's reality, they wind up understanding commonalities instead of magnifying differences. Now, this is a really interesting application of VR and AR. Imagine if we could allow you to spend a day living a life that is not yours and finding out how it actually feels. These are experiments that are really expensive and time consuming to do in real life, but we could do this kind of thing in elementary schools and middle schools as a routine thing. I think that'd be a fascinating application. I think there'd be tremendous interest in it from young people who tend to be open to new experiences like that. And that could create a kind of understanding among people that we've never really had before. I think that'd be really exciting. Someone mentioned Philip K. Dick. Oh gosh, if we were to make a list of all the movies that are derived from Philip K. Dick stories, I mean, Paycheck is one of his. Total Recall is one of his. I can't even come up with all of them myself. The Man in the High Castle, which was adapted by Amazon, is from, I believe, one of his. Yeah, he's been an amazing source of ideas. What's the name of the metaverse tool we used for our meeting? It was an application called Glue, GLUE, spelled like adhesive. It's been improving at an astonishing rate just since we used it. We've already had some of our iconic Salesforce meeting spaces, like the meeting floor at the top of the tower in San Francisco, has been reproduced as a Glue virtual reality space, and so we're using that now for some of our meetings. It's been really exciting. Someone asked, oh, the picture behind me. Oh, well, that's always a fun one to answer. That's a quilt. Believe it or not, there is no paint or pigment involved. That is completely constructed by carefully chosen pieces of fabric to interpret a photograph from National Geographic that my wife, the artist of that object, liked, and she got the photographer's permission graciously given to do that work based on that photo and exhibit it. And it is of a place called the Callender Stones, an installation called the Callender Stones in Scotland. So a Stonehenge-like place, but not Stonehenge. But that's what the backdrop you're seeing there is. And I always enjoy answering that question.